Hello and welcome to lesson 1 of week 9. We're going to rationalize the denominator today. So you'll understand what that means in a little bit, but we're going to rationalize a denominator that contains a radical and express the answer in its simplest radical form. So we're going to connect what we're about to do to something you already know. So we're going to add these fractions. Hopefully you remember from middle school that to add fractions, you need to have common denominators. To do that, I need to multiply the first fraction by 2. 3 times 2 would give me 6, and that would give me common denominators. But I can't just multiply the bottom by 2. I got to multiply the top by 2 as well. So that gives me 4/6 plus 5/6, which gave me 9/6, which you can reduce at the end to 3/2. So there's a proper form for radicals. We'll go back to radicals now. You cannot have a radical sign in the denominator. You just can't do it. So if you have an answer like this, can't do anything with that any further. I can't reduce the 3 and the 5. I can't do anything with, but I can't stop there because I have a radical in the denominator. It's not allowed. So what do we do? Well, watch what I'm going to do here. That step right there, multiplying the top and the bottom by radical 5, that's the rationalizing the denominator step. It's the rationalizing step. So it's going to do something to the top. It's also going to do something to the bottom. So the top becomes 2 radical 15. The bottom is 5 times 5, which is 25. But why is that helpful? Well, now I can write that as square root of 25 is 5. And I've gotten rid of the radical in the bottom. 2 radical 15 over 5, if you type that in a calculator, you will get the exact same decimal as if you did 2 radical 3 over radical 5. They are identical. They just look different. Okay? So we're going to do several examples here. So hopefully you see right away, square root of 49 is a good number. It's 7. But the bottom is not. Square root of 75 is 25 times 3, which is 5 radical 3. I still have a radical in the bottom. So now I got to do the rationalizing step, which is multiply top and bottom by radical 3. Why radical 3 here? Well, it makes 7 radical 3 on top. Radical 3 times radical 3 is radical 3 squared. The radical and the squared cancel. And I'm left with a 3 times the 5 on the bottom. Put everything together, and I get 7 radical 3 over 15. Here's another one. A lot of people think, oh, just divide the 20 and the 5. Problem is the 20 is outside the radical, and the 5 is inside the radical. I can't put those together. So I have to go straight to the rationalizing step. The top, 20 times radical 5, I can't put those together. So it's 20 radical 5. Square root of 5 times the square root of 5 gives me 5. Because it's 5 squared, it cancels the radical. But I can now reduce the 20 and the 5 because they're both on the outside of the radical. 20 divided by 5 is 4. And then the radical 5 goes at the end. Okay, now let's throw some variables in. Doesn't really change much. I'm going to go ahead and reduce this. Sometimes that will help me and get rid of the radical by putting a perfect square on the bottom. In this case, it doesn't. I can take 7 out of both of those, and it leaves me with the square root of 2 over 3x. There's still a radical in the denominator. So I'm going to multiply the top and the bottom by the square root of 3x. What that does is it makes the top the square root of 6x. I can multiply the 2 and the 3x together because they're both under a radical. So square root of 6x over 3x times 3x. That's 3x squared. It cancels the radical, and I'm left with just 3x. And that's as far as I can go with that one. All right, let's do another one, a little more complicated fraction. Reduce what you can. 40 and 35 reduce to 8 and 7. And divide both those by 5. There are 4 more a's on the bottom. So now what I'm going to do is I'm going to simplify on top as much as I can and the bottom as much as I can. So 8 is 4 times 2. The bottom is the square root of 7 times the square root of 8 to the 4th. Well, the square root of 4 is 2, radical 2. And the square root of 7 I can't do anything with, but the square root of 8 to the 4th is a squared. I still have a radical on the bottom, though, so I need to rationalize. That's radical 7 over radical 7. The top is going to become 2 radical 14. Because the 2 inside the radical can multiply with the 7 inside the radical and make 14. And then a squared times 7, right? Radical 7 times radical 7 makes 7 no longer under the radical. So we write it as 7a squared. That's as far as I can go with that one. There's no reducing that I can do. I'm checking at the end. There's a 2 on the outside and a 7 on the outside. Sometimes those can reduce. This time they can't, which means I'm done. Okay. And so you just saw a bunch of examples of how to rationalize the denominator. Not all are as tricky as this one, but they all have, when you rationalize the denominator, they all have this step that you're seeing right here in red. Okay, so that's what we're working on with this lesson. And that concludes lesson 1.